Hello everyone. In this video, I will be discussing about the term dimensional analysis. So it is part of unit number 3 under SPPU fluid mechanics syllabus. Firstly, we will see about the definition of dimensional analysis. So in general, if we talk about the phenomena or problems associated in the fluid mechanics, so there are certain problems which requires many variables, and to solve variables, for each variables we require each individual equation. So in that case, if we are having a big problem statement, so there can be the involvement of many variables. To solve such many variables problem, we need some extra equation. So dimensional analysis, it is a mathematical technique which is mostly used to solve the complex problems of fluid mechanics. So these are the problems which cannot be easily solved or identified with the help of some basic principles of fluid mechanics, or you can say some basic theorems of the fluid mechanics. So such problems can be solved with the help of definition dimensional analysis. So here also in definition on the screen you can see, it is a mathematical technique used to solve problems of fluid mechanics which are very complex in nature and also very difficult to solve. So yes, this is the definition of dimensional analysis. Now we will be seeing fundamental quantities or fundamental dimensions. So to use this technique, we should know the fundamental quantities or fundamental dimensions. So basically whatever principles we study in fluid mechanics, those principles will be directly or indirectly dependent on the physical properties, or you can say physical quantities. Those quantities we have already seen in the subject fluid mechanics earlier, maybe in the first year of engineering or in the diploma. So those physical quantities are nothing but as we all know, length, mass, time, temperature, etc. So these quantities we call as an physical quantities or fundamental quantities, right? So in association with these physical quantities only, so there are certain quantities, certain physical quantities. The unit of those quantities, if it is not dependent on the unit of the another physical quantity, so such quantities we call as an fundamental dimensions. And remember one thing, to study this dimensional analysis, so we need to understand the term fundamental dimension. So yes, if the unit of physical quantities, if it is not dependent on the unit of any other physical quantities, that we call as an fundamental dimensions. So basically we are having three basic fundamental dimensions, that is m, l and t. M for mass, l for length and t for time. Yes. Now we will be discussing about the first topic of dimensional analysis, that is dimensional homogeneity. So to study the technique dimensional analysis, the equation, what is the problem statement or whatever the equation is there, that equation should be dimensionally homogeneous, right? So to study dimensional analysis, first we need to understand what is dimensional homogeneity, right? So if suppose there is an equation and if we have to check the dimensional homogeneity of that particular equation, so basically the meaning of the dimensional homogeneity is nothing but if we take the dimensions of both the sides of the equation, that is left hand side of the equation and the dimensions of the right hand side of the equations, if we compare those two dimensions, and after comparing, if we get to know that those two dimensions or the dimensions of both the side, if it is equal, then at that moment we can call it as an dimensionally homogeneous, or that particular equation as an dimensionally homogeneous. Homo means same, means dimension of that equation, if it is same on both the end, so that term we call it as in dimensionally homogeneous. So there is one question which is asked in SPPU examination, December 2015 examination. This question has been asked, which is for 2 marks. So the question is something like this: explain the principle of dimensional homogeneity and check dimensional homogeneity of a given equation. So firstly, what is the question? We have to explain first that what is the principle of dimensional homogeneity. Okay. So basically in this we have to explain the principle in 2-3 lines. this can be for 1 marks, as total question is for 2 marks. So first half portion is for 1 marks. Now next is, and check the dimensional homogeneity of the equation. Equation is given in the question. So we have to check whether the given equation is dimensionally homogeneous or not, right? So to check this equation, whether this equation is dimensionally homogeneous or not, we have to equate the portions of right hand side and left hand side, portions of dimensions. Okay, you remember dimensions of both the ends we have to see first. So here if you can see, I have taken the dimensions of left hand side. In left hand side of the equation we are having only HF. HF is nothing but it is head loss due to the friction. It is already given in the question. The formula or both the sides of the equations are given in the question. So HF is nothing but head loss. Head loss we measure in terms of meters of water, right? So that meters of water we can write in terms of dimensions as length, right? For any dimensions which is linear, that is meter, meter square and meter cube, so that can be represented with the dimension L, right? So we are giving this equation as equation 1. Now we will take dimensions of right hand side. So in the given equation, the right hand portion is nothing but FLV square upon 2GD. Okay, so now we will be writing the dimension of right hand side. So on right hand side, the first term is F. F is the friction factor through the pipe or the friction factor in the pipe. So that is a constant, it is not the quantities. So there cannot be dimension for this constant. So that you can keep as it is F, or you can make it as an 1 for that particular constant. So L is the length of the pipe. So length we measure in terms of meter. So for L the dimension will be capital L. Now next is the velocity V. So velocity V is nothing but it is the velocity through the pipe. So we will write the dimension of that velocity. So velocity we measure in meter per second. So one of the way to write the dimension is, firstly to remember the formula, that is velocity, it is, we are having the formula rate of change of displacement with respect to time, means it is length L upon time T. First way is with the help of definition and second way is with the help of unit. So these are the two ways to write or to identify the dimensions of a particular. So we will write the dimensions of velocity, that is L upon T. So it is here velocity square. So whole bracket square I have kept it here. So now we will write the dimensions in the denominator. 2 it is a constant, so there cannot be the dimensions of a constant or a number, right? And g is the acceleration due to gravity. Unit we know, the best way to write the dimension is with the help of the unit. Unit of g is nothing but it is meter per square second. So meter for L, square second it is t power 2 or t square, into diameter, d is the diameter, which is in terms of dimensions we can write as L. So on rearranging and cancelling the common terms from this equation, we will be getting only L. So this equation we can term as an equation 2. So if you compare equation 1 and 2, what you can observe is both the sides of this equation, or what you can observe is it is same. Equation 1 is equal to equation 2, that is the dimensions of left hand side is equal to the dimensions of right hand side. So hence the statement, the equation HF is equal to FLV square upon 2GD, it is dimensionally homogeneous equation. Why? Because the dimensions of left hand side is equal to the dimensions of the right hand side.